All right, hello, my name is Ruth Roberman. Thanks for watching. I'm going to create several short videos just to give you some overview of the big ideas that we're going to cover in week 1. They'll be separated in separate videos. You'll see all the links though, so they'll be easy to find. But hopefully this will help you get started. You can see that in week 1 we're going to cover basically systems of equations and how to apply them to real-world situations. The one thing I want to caution you about is to please make sure that you go to doc sharing and make sure you look for the PowerPoint presentation. It's going to match this. It's going to be all in one set of slides, and what you can do is download that and you'll get a ton of examples in addition to the ones I'll show you here. All right, quick review. I shouldn't have gone through that quickly. Quick review is of graphing and plotting points. And just to show you here how you can plot points, it takes 2 points to determine a line. So if you plot 2 points, you can connect them and you've got your line graphed. So if I wanted to plot the point 6, 4, I have to go right 6, starting at the origin, go right 6, up 4, place my dot. Okay. Now I'm not creating a line with this, I'm just showing you some plotting point examples. And if I wanted to create the point -6, 0, I would start again at the origin and go left 0, up nothing. So left is your negative and down is your negative. So here's one, the point -3, -5 has 2 negatives. So if I wanted to use that point, if I wanted to plot that, I would start again at the origin, 0, 0, and I would go left 3, down 5, and there's my point. So if I wanted to plot a line, we could do the exact same thing, except just plot 2 points and connect the dots. Now, how do we know what x is? Well, x can be whatever you want it to be, and y will be whatever you calculate it to be. So as you see in this example, I've got y equals 2x plus 3. So what I'm going to do is let anything be equal to x. You see a lot of choices. I think 0 is nice and easy, so let's look at that. And all you're going to do is put 0 in place of x in this equation. And when you do, you get 2 times 0, which is 0, plus 3, 3. So my point is right here, 0, 3. And I'm going to plot that, which means I'm going to start at the origin and go left or right 0, up 3, and that's my dot. All right? I'm just going to do one more for this example. Let's say I'm going to pick 2. And again, I can pick anything I want for x. Again, I put that back in place of x in my equation, and I get 2 times 2 is 4, plus 3 is 7, and that's my second point. And then I will start the origin again and go right 2, up 7, place my dot. And that is enough for me to connect and draw my line. And you just connect those 2 dots in a nice straight line, not like that. But I think it's a good idea to always create a third point just to make sure that you haven't made a calculation mistake in the 2 that you did. So why am I talking about graphing? Well, we're going to talk about graphing when we look at a system of equations as one of the methods to solve it. All right, so that's why we need to do a quick little graphing review. All right, so let's say we had a word problem, and T-shirt Villa sold 52 shirts, one kind at $8.25 a piece and another at $11.50 a piece, and they took in $464.75. How many of each were sold? Well, if we said, well, maybe 26 of each, because 26 plus 26 adds up to 52, that would be incorrect, because you can see our total would not be what we indeed collected. So guessing is never the right method, all right? So you never want to use the guessing method. We want to use algebra throughout this whole course. And the first thing we need to do in a word problem is to set up a table in many cases. I'm very visual, so setting up a table helps me a lot. And you can see this table here, all right? So I've got the pertinent information, the price per shirt, the number of shirts. Well, I don't know, so I'll call the first shirt X and the second Y. I know I've got 52 of them, and I know the one shirt was $8.25 a piece and another was $11.50 a piece. So we're not going to solve this in this at this point, but I just wanted to show you the setup. We've got this equation, and then I've got this equation, okay? And that gives us two equations, which means we've just created a system, and we will learn later how we can actually go about and solve that. Now, a solution for a system is where two lines intersect. So they will either intersect at one point, they will overlap, which means they'll have infinitely many points, or they'll have no points of intersection. In other words, they would graph to be parallel. All right, so if I wanted to know if 1, 5 is a solution to that system, 1, 5 may be on one line, but not on the other. So the only way it's a solution is if it is on both lines. So what you're going to do is just take 1. Remember, a point is an XY order, right? So, and also remember, points are always inside parentheses. That's a common mistake. So they're always in XY order. So this is X, and this is Y. So in place of the first equation, I'm going to put 1 in place of X and 5 in place of 4. Here's my first equation. And I get a true statement. All right, that's a true statement. I'm going to do the same thing to the second equation, and I get a true statement here too. And because I get a true statement, I can say that this point is a solution to that system. Now, as I said earlier, we can solve a system graphically. And if we can solve a system graphically, that means we will actually plot the two lines on one set of axes and see where they intersect, if they do at all. So here's a system that I plotted. If you need any more of a review on graphing, just ask me. I've got tons of resources, and I definitely encourage you to go to purplemath.com for tons and tons of resources. Anyway, what I've done is plotted these two lines, and if you're wondering how, I went off on my scratch paper and I did my X, and I picked a value for X, found the value for Y, had a point, did it again, plotted that line, plotted the other line, and I got this. And what I found is that the two lines intersect at the point 3, 2. Now, if you're thinking, man, what if I'm not so straight with my line? That's going to be okay, because all you have to do is go and plug in that answer, our claim that 3, 2 is the solution, pop that into each original equation, see if you get a true statement. If you do, it'll just confirm that, yes, you are correct. Now, I'm going to skip this slide for this quick little video, but I do want you to just see that I do go over in the PowerPoint a very detailed explanation about how I graph those two lines, and I don't want you to miss that. Okay, here's another example. Same procedure. I picked a value for X, found Y, got a point, did it again, pick a third point just to make sure, plot a line, did the second line. And what's interesting here, and you always want to extend your line because it might intersect farther out than you think, but looking at this, they are parallel like railroad tracks. And that means they never intersect, so there's no solution. And that can happen. And then I have a situation like this where I plotted the line and it overlapped. Turns out that each line was the same line and it overlapped, and that means there's an infinite number of solutions. Every point on one line is on the other line. Okay, so you can see our three situations. We can have one point in common, and that's called consistent. We can have no points in common, and that's inconsistent. And we can have an infinite number of points in common, and that's called consistent. So basically, if you have one or infinite points in common, it's consistent. If there's no points in common, it's inconsistent. All right. And this is just an example of basically what we just saw when you have an overlap situation. I'll let you look at that on the PowerPoint presentation. All right, I'm going to end this video. The next video, we're going to talk about the substitution method.